So here's a question. Why do we need to think about vertical asymptotes algebraically? Can't we just see it on the graph? So can you reliably detect vertical asymptote by graphing? Can you construct a function where you know it has a vertical asymptote, but it wouldn't show up on a graph? Kind of hard to think about. Let me offer a suggestion. How about 1 over x minus 10 to the 100? 10 to the 100 is a 1 with 100 zeros, and there's a name for that number, and it is Google, but spelled this way rather than the company name. Google, the company, actually kind of got its name from this. So does that have a vertical asymptote? Well, let's go check the graph. All right, here's our graph of 1 over x minus 10 to the 100. I do not see a vertical asymptote there. It looks like a pretty boring function. Let's go back to paper and pencil. So a graph on the default x window didn't show a vertical asymptote. Well, maybe we just weren't looking at the right window, right? We should look at other x windows. Where should we look? We need to look for x values that might cause a divide by 0. So algebraically, we need to look for what x values might cause divide by 0. And then we can use that to set our graphing window. So I'm asking about divide by 0 because we know that often produces a vertical asymptote. Here, what x value would produce divide by 0? So we'd say, well, when that denominator is 0, which would be when x equals 10 to the 100. So let's go try that. We need to enter some range in Desmos that includes 10 to the 100. All right, so here we are. Our default graphing window does not include 10 to the 100. We'll come up here and set our graphing window to include maybe 2 times 10 to the 100, go twice as far as we think we need. Doesn't really matter what the other part is here. And I do not see a vertical asymptote there. Looks pretty boring still, so maybe I was wrong. Or I have to think every little step here is going by 10 to the something huge, like 10 to the 99. So by the time I get away from where my vertical asymptote probably is, my y values have probably shrunk a lot. So if I go and zoom in extremely on y, how about minus 10 to the negative 99 and 10 to the 99? What do you think? Well, 99 was just kind of a guess based on 100. If I start zooming in and keeping that in my sights, oh, I'm at 10 to the positive 96. Let's go. Maybe Desmos didn't see that I wanted 10 to the negative 99 and 10 to the negative 10 to the negative 99. Okay, there we go. Oh, there we go. Just zooming the wrong way. All right, so because the algebra told us there should be an asymptote there, we persevered and finally found where it was, even though we had to really do interesting tricks with the Desmos window and everything. So that's the power of algebra for you. I have another question that we'll do paper and pencil. So here's my new question for you. Can a curve cross a vertical asymptote? Try drawing something that maybe crosses a vertical asymptote and comes back to it. So one way to think of it is, here's some vertical asymptote I want, and I'm going to have a curve come in here, cross, and then come back and maybe cross again and do something like that. Or maybe cross and then not cross again, but zooming off to infinity. What do you think? That's a perfectly good curve, but is it a function? Well, if I drew another line here, just barely off from my asymptote, it would cross that line twice. Here it's crossing that line more than twice. So these are not functions. They fail the vertical line test. They're curves, but they're not functions. So a function cannot cross a vertical asymptote. Now, we have to think more carefully about what we mean by cross a vertical asymptote. Here it kind of crossed and came back. What we don't mean is something like 1 over x squared or 1 over x. Those you might say, well, I crossed the vertical asymptote, like I didn't hit a brick wall, there were still values over here, but the function didn't try to be equal to the x value of the vertical asymptote and then come back to it. There was no x, there was no y value at the x value of the vertical asymptote. Okay.